Welcome to another Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and we have a special guest tonight. We're going to be diving into a great topic, something that I'm still learning a lot about. I've done a lot of sizing of equipment when I did work at a manufacturer, but we have an expert tonight who has helped develop many of the softwares for it, or has been involved in developing a lot of the softwares over the years for a lot of different manufacturers. And I'm super excited to dive into this because I want to find out, there's some things that I really want to understand how to, fine tune your selection, get a better understanding of selecting the right equipment, because I see a lot of equipment out there that is not sized correctly. And I think this is really going to help a lot of us out here. Andy, welcome to the Refrigeration Mentor podcast. How you doing?
I'm doing very well. Thank you, Trevor, for having me.
Andy, why don't you dive into a little bit of introduction of yourself? Because I know you've been in the industry 40 years and there's a lot.
45 years. 45 years.
45.
I tell you, I'm an oldster, but that's okay. Most of my 45 years in the industry has been, I've been involved as a product manager for manufacturers of refrigeration flow controls. And the past employer was Sanwa that I worked for 7 years. They're perhaps best known as the largest supplier of reversing valves in North America. They are by far and away number one. Worked a couple of years for Dunan, which is a competitor of theirs. Sanwa ended up dragging me on over to their side of the fence when they found out I was there. And I spent 27 years mainly as a product manager for Sporlan Valve Company.
And not many people know who Sporlan is in the refrigeration industry.
But it's and I was 27 years, and that's where I learned the trade. They had a really large group of talented people, and I really learned the trade at Sporlan. And I worked for them up until the point where Parker Hannifin purchased them, and I worked an additional 6 years for them. I ended up leaving them to work for Tecumseh Products in Ann Arbor, where I learned the compressor trade along with unit cooler and condensing units. And they did allow me to run their Tecumseh University. So I was responsible for the curriculum and putting on the classes, primarily for the refrigeration wholesaler personnel, just to make sure they understood how to size equipment, that sort of thing. So that's a time that I enjoyed quite a bit. And I am still, I'm a life member of ASHRAE. I am still involved with their technical committee, specifically TC 10.1, which is Engineered Refrigeration Systems. I am called upon every once in a while by Nate as a subject matter expert. And I've been involved with RSCS since 1983.
Wow.
And so that's
a lot of refrigeration history there. And I'm sure it's just working at a manufacturer like Sporlan over the years, and especially the long time you were there, you would have seen all the top talent, in the industry, because they might have come to Sporlan for a few years and stayed for a long time, but some moved on, started their own companies or went to other companies to grow their careers as well. So and then going to all these events like RSES when it was big and huge, when you're talking about hundreds and hundreds of the top talents around North America, the world, come into these events. So I'm sure there's a ton of history you can talk about. Let's just talk a little bit before we dive into this, a little bit about Sporlan. All of us know Sporlan TX valves. I know you were the product manager of that.
Mhm.
Tell us a little bit about the history coming, because you started in the early 80s with that.
Yes,
Just before we get into
absolutely.
to training and getting into sizing and selection, talk a little bit about that history of the evolution of the TXV or TEV. I can't remember
Yeah,
what Sportland calls it.
yeah. They prefer the TEV
Yeah, that's right.
simply because their main competitor at the time being Alco. Back then they were still called Alco.
Yeah.
They preferred the TXV acronym. So that's just to be different. But back in 1983, of course, there were three main refrigerants: R12, R22, and R502. And I learned from what I consider the best. And I can still remember being at Sporlan, the ACHR news back in 1986. They came out with this nice little article uh, saying that there was an ozone hole. And I can clearly see that. And I'm thinking, holy crap, things are going to change here.
Yeah.
And I remember that day so well. And of course, it's been kind of a roller coaster ride since that point. And industry switching from the standard safe A1 refrigerants and going into the HFC refrigerants, and Sporlan adjusting to all these new refrigerants, and end up going into the 1990s where Carrier decided to go to 410A, and we're looking at these pressures saying, holy crap, you know we can't handle the life cycle tests on our TEVs with these pressures. So we had to redesign the expansion valve. And to Sporlan's credit, they did it first. They were able to get a 410A expansion valve to work. And
Nice.
if folks remember that time period, uh, Carrier did not come out with a unit right away with an expansion valve because they were having issues with the oil at that time. There was a compatibility issue with the oil, and they were plugging up the Sporlan expansion valves. It's kind of like, it's not our fault.
Yeah, no, no, I've heard that many manufacturers always it's a compressor fault, it's a TXV fault, it's not the person who built the equipment. A
Yeah,
lot of the time, I've heard so
they had
much of
all
that.
this crap filling up the valve. So, but they in time they got that straightened
Yeah,
out, and sure enough, time went on, and now of course we're in a period where 410A is it's
it's got 8 months left. I think
yeah,
that's what, or 9 months.
it's
That's it.
it's kind of over for them. It's
Yep.
on to A2Ls and that sort of thing.
Yeah. So a huge evolution you've seen there, and it's happening again. You know what I mean? We're at the
Yep.
tipping point again where new valves come out, and I've seen all the manufacturers have to adjust. You know what I mean? And this, it doesn't. You can't just change it overnight. It doesn't. You got to test it. You got
Oh,
to involve it. And there's so many workarounds
there'll
people talked about, but it's a lot of work.
there'll be a hiccup or two when they start using these new refrigerants.
Oh yeah. Well, it's only 20 degree glide. It's no big deal, Andy. That's it. 20-degree glide. We got that. Awesome, awesome. I love hearing that. So let's start getting in. Let's dive into a little bit about you, because you are the founding member of the HVAC advisors.
Yep.
I found you probably about a year and a half ago, and I was on your website and I was doing some line selection, and then I talked to my friend Dick Wers, and he said,
Mhm.
"Oh man, you should get in contact with Andy." This was actually last year, and I'm like, Andy, where did I hear that name at? Where did I? And I'm like, oh man, this is the guy who has this website that I was using the line selection, because before I was using maybe it was Tecumseh one. You probably built that
Well,
one. You know what I mean?
yeah, I did that one. I
Yeah. So
I as it turns out, I've improved on it since that time.
It's awesome. Oh, it's awesome. So let's get into let's dive into it. Like let's because a lot of people want to find out and get a better understanding on how to size refrigeration equipment properly. I think this is a
Okay.
big conversation.
All right. Well, yeah, by the way, Dick Wirtz is a good friend of mine, and I've
Oh,
known him for many, many years.
such a great guy, a stand
Yes.
up guy.
All right. Let me share my screen here and see if I can get this thing working.
Yeah. And for those who are listening on the podcast, we'll do our best to explain stuff, but you can always follow back to the YouTube video that'll be in the description.
All right. This is just a few slides that I wanted to show. I thought I would, speed things along here a little bit. But I've been, since retiring from San Juan, I've been running a consulting firm for the past couple of years. What basically happened is I have a lot of people who've known me for many years, and they asked me to do things, and I decided that I better start charging for my time. So there you have it. I'm now a consulting company.
There you go.
Um, uh, when talking about uh, walk-in cooler freezer equipment selection, you get into this kind of interesting topic of AWEF. AWEF being the annual walk-in efficiency factor. And it is something that the DOE, U.S. Department of Energy, has put together. They are, um, by law, under Congress, allowed to set efficiency standards for appliances, which has kind of grown to a lot of things, including, computer hardware and whatnot. And they got around to looking at walk-in cooler equipment systems fairly recently. They've been doing residential air conditioning heat pumps for quite some time, and they've established a standard for efficiency for these walk-in cooler and freezer equipment. And just to kind of give you an idea of the history, the original procedure was published in 2014. It was supposed to go into effect in 2017, but there were problems with the test.
Yeah.
Yeah, there was problems. In other words, the manufacturers said, "Hey, this doesn't make sense."
No.
So they got together, worked it out, and they had it figured out by 2020. So as of about 3 years ago, walk-in coolers and almost 3 years ago, walk-in freezers now have to comply with the AWEF requirements. Now, if you want to see the test procedure, it's available free online at the AHRI website. However, I might suggest to you that you go to my site under the cold topics section. You can read the article. I wrote an article, tried to make it as concise and as clear as possible what they're trying to do with the AWEF standard.
Yeah, I've done a ton of training on them when I was when I was working at Emerson, and it just for me to figure it out. And I had people telling me, talking me, walking me through it, and I was still confused for the longest time until like finally got it because there was that period from 2015, 2016. I didn't have a clue, but around 2018, 2019, I finally was clicking in on it because there is a lot to it.
Yeah, in my article, I actually show this table. There is actual AWEF efficiencies. They are in BTUs per watt hour, uh, which is the same for SEER, but obviously the tests are different. And they have an AWEF requirement for both indoor and outdoor condensing units, and they have a separate one for unit coolers. In the field, you're normally matching up a condensing unit with a unit cooler. Most of them are not sold as a system. So it was necessary, and that was one of the early problems is that the DOE had to figure out a way to rate just a condensing unit without a unit cooler,
Yeah.
and they
Head
worked that out.
scratcher. That was a head scratcher. And the funny part is, when this was coming in, the refrigerant regulations were coming in at the same time.
Oh, absolutely.
Yeah,
It was a kind of a double whammy, but I'm actually wasn't even planning on getting into that subject
no, we
here.
don't have to.
But there are exceptions to the AWEF requirements. In other words, it is not necessary to install AWEF compliant equipment for certain systems. Now, any walk-in that has a floor space 3,000 square foot or greater, you do not have, you're not required to put AWEF compliant equipment. The theory being is that the DOE figured that they're going to be engineered systems anyway. So, they were only interested in the smaller walk-ins with their energy efficiencies. Any compressor system with a remote condenser there's no AWEF requirement at all. Water-cooled condensing units, no. Interestingly enough, if you've got specialized systems for medical or scientific applications, there's no AWEF requirements either. Any multiplex systems, like compressor racks that you would have on a supermarket system, AWEF doesn't even apply. And they do allow in the compliance rules that if you do find a condensing unit or unit cooler that was manufactured prior to the compliance date, you can still use it. They didn't want,
Yeah.
necessarily for wholesalers, whatever, to scrap equipment or manufacturers of scrap equipment. So you find an older piece of equipment, sure, you can use it. So that generally brings up an interesting question in that are retrofits exempt? Let's say you're working on a walk-in and you only want to replace the unit cooler or you only want to replace the condensing unit. You don't want to replace the whole system. Are they exempt? The answer is no. If you have to replace a condensing unit that must, on a walk-in that is required to have a AWEF compliant equipment, you are expected to put AWEF compliant equipment in there. Retrofits don't exempt you.
Yeah. And I know, talking to people about that, they're like, well, what do you mean? If I move it, I got to take out this good evaporator that's working totally fine. You know
No,
what I mean?
you don't have to take it out, but the condensing unit that you're replacing, yes, it has to be compliant.
Yeah. And then I know lots of people, well, what if I just change the compressor on it? Is that okay if I leave it? You know what I mean? So there's a lot of things that
Well,
people,
yeah,
if you're changing the compressor anyway, like,
yeah.
how old's the equipment?
And the next question comes up, who's responsible for all this? Now, the the equipment manufacturer is responsible for determining if their equipment is AWEF compliant. It is their responsibility. You get something from like a heat craft saying this equipment is AWEF compliant, you're good to go. You don't have to do anything else. However, it is the installer's responsibility for using AWEF compliant equipment when required. So, if the installer finds some equipment that's not AWEF compliant and installs it when it should be AWEF compliant, they could be hung for that. So that's where you have to be cognizant
Yeah, I don't even know if the installer a lot of them even notices because it's passed down through the whole the manufacturers to the wholesalers, and they're you know what I mean. And I think the way it's getting to the contractors, they probably a lot of them don't even know, you know, but they're
Well,
buying a WEF equipment because like here in Canada, for example, Keep Rights here in town, it's
yeah,
just all AWEF equipment now, so they wouldn't
yeah,
even know
and
if
it's
it's that or not.
one
Right?
other question that does come up is that must you use AWEF compliant equipment in Canada? The answer is yes, because your group up there, the National Resources of Canada, whatever, NRCan,
Yep.
they're they came on board with the DOE when they came out with the ruling.
Yep. So it's all done now. So it's North America wide. So well, Canada
Yeah,
and the US
yeah,
anyway.
basically, yes. All right, and then finally, we'll just what do you really need to know to size the equipment? And some of this should be basic to many of you, but you need to size the unit cooler for the proper temperature difference. You need to know the storage temperature. You need to know the design ambient temperature for the condensing unit. You need a heat load estimation. And obviously, you need to make a determine, is this particular walk-in, does it need AF compliant equipment? And just make sure everybody's on the same page with evaporator temperature difference. That is defined as you're entering air temperature into the evaporator minus the evaporating temperature, the refrigerant temperature in the evaporator. Do not confuse temperature difference with delta T, the temperature drop of the air, which in this particular example, we have a TD of 35 minus 25 or 10 degrees, but only a air temperature drop of 35 to 30 or a 5-degree delta T. So
So
having knowledge of
so
delta T is good, but for sizing purposes, you're only interested in TD.
and I have people that say TD is the your SST and your leaving air temperature.
No, nope, nope.
You'll see in manufacturers equipment that how they do, they'll say they want the discharge air temperature when they're using CDS valves. So
Well, yeah, in the case of a CDS valve, which controls discharge air temperature, it's that's a different control.
yeah,
But
so
with in the case of a unit cooler,
yeah,
TD is what you want to size the unit cooler with.
right. Yeah. So it's good just to make that because you want to make sure when you're talking, and I say this all the time, when you're talking to a different technician in refrigeration or HVAC, just what you just did there is exactly what I say. Are we talking about delta T? Are we talking about TD with the entering air?
Mhm.
Or are you talking about TD at the leaving air because of open air cases with CDS valves? And I have to make that clear because people confuse them, just like you know what I mean. We're talking about there, so
Yeah.
I have to be aware. But the original TD is air entering for and your SST.
Your SST, exactly. Um, the TD, and when you take a look at the unit cooler capacity charts, all of them use a 10-degree TD for rating purposes, which is fine because 10 degrees is about where you normally want to be anyway for most of your walk-ins. Now, if you happen to be just cooling beverages, you've got a beer cooler or whatever, you can run that up a little bit to like 15 or anything that's short-term packaged products. Floral cases, they like keeping the TD even a little bit lower if possible, 8 degrees. And just for curiosity, if you happen to be doing wine rooms, they even like higher TDs up to 18. They don't want a real humid cooler in there. They don't want condensate anywhere on the nice wine bottles or whatever. But for the most part, you can use 10-degree TD for sizing unit coolers.
So why don't you talk about that a little bit on the TD versus the relative humidity that that coil will cause in a box, because that's
Yeah,
important. I don't think a lot of people talk about that. So
yeah. And on this particular table, I did include the approximate range. Now, again, it's approximate
yeah, yeah.
because you know you don't know the entering conditions of the air, but when you're operating at a 10-degree TD, you're typically 80 plus on the relative humidity in that walk-in, and and that's fine for most of your applications. The other nice thing about having a fairly low TD is that it does allow these equipment to operate more efficiently. When you start raising that TD up, your 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 pressure ratio across the compressor goes up and it doesn't operate quite as efficiently. So
Mm.
um, you might save some money, with a smaller unit cooler, but for the most part, 10 is where you want to be. An 80-degree RH is good, and you want to reduce that RH, for certain situations like a wine room or a prep room, that type of thing.
And so just before we dive in a little bit more, to get a bigger TD, how do we are we going to talk about that? We're going to dive in how to get a bigger TV on
Well,
a coil?
yeah, and in fact, I wasn't going to dive into too much, but uh, if you size a unit cooler for a 10-degree TD, if you change your mind and want to go to a 20-degree TD, what you need to do is find a unit cooler with half the capacity. So you the TD is proportional to the capacity of the unit cooler. So
Awesome.
at a 10-degree TD, if you got a 6,000 BTU unit cooler, at a 20-degree TD, it will deliver 12,000 BTUs.
Thank you for
Yeah. And here's just a little table on temperatures. You can get real extensive on this, but for most part, this will work for most of your applications. Any cooler application, your temperature, your storage temperature should be around 35, 37 degrees. Frozen foods, 0 works very well. I know some people like to see
let's
ice
drive it
cream
down.
cases.
Let's
Let's
get
get
it
it
colder.
further.
Let's get it colder.
Well,
Drop that suction.
yeah, I personally, I've never seen the need even for ice cream to be at -10, but some people like it down there. So
Man, that's all. I've seen so many racks that I go in and it's just like just drives it down so cold. Like why? Why are you running everything so cold? Like, but that's it. Okay, good,
yeah,
good.
all right. But the other thing that you need to figure out is the design ambient temperature. And what I did in this particular table is I identified the top 10 metropolitan areas in the United States and their associated weather stations. And this particular table shows you what the design ambient temperature is for those locations. Now, this information is available from ASHRAE. The ASHRAE Fundamentals Handbook has a very extensive list of temperatures that you can look up. So, for example, in my area in Dallas, we have a kind of a nice high ambient temperature, 101. So, and you need to know this so that you can make sure that if you're sizing a outdoor condensing unit, that you make sure that it has the capacity you want at the design ambient. Now, you'll note that on this table, I note the 0.4% ambient temperature. Now, what do I mean by 0.4%? What that means is that on average, the total percentage of hours in a year that that temperature will be exceeded. So if you do the math, there are 8,760 hours in a standard year, non-leap year. And if you multiply that by 0.004, that comes out to 35 hours. So any of those temperatures that you saw in that chart, you can expect on the average maybe 35 hours out of the year that those temperatures will be exceeded. All right. Now, ASHRAE goes through the trouble of not only publishing the 0.4% temperatures, they publish the 1 and the 2, which are subsequently a little lower. And you may wonder, well, which one should be the ones that we use? Well, the folks who write the TC committee that does the chapter on load calculations, they use a 0.4. And I figured that I'm not any smarter than the guys on that technical committee, so my software uses 0.4, as I believe most of the other programs out there also do that.
So now, what's in saying this, so there's 35 hours a year for these warmer temperatures, but most of the system's way oversized for 35
Yeah,
hours a year.
that's right. You have to pick a point, and it's all statistics, of course, and someone can make an argument, well, the 2% temperature is probably just fine, and then they may well be right. But you have to pick a reasonable design temperature for an outdoor condensing unit.
Yep.
And 0.4 seems to be the generally agreed upon level to pick that temperature. And what I'm showing here, and I'm just picking on Heatcraft because I can. I've done very little business with Heatcraft, but they do publish some very nice tables. And the whole idea, is in sizing equipment. Once you know your design ambient, the capacity you want, the TD you want, you can go to these tables and select a condensing unit cooler. They have, unfortunately, in the case of Heatcraft, they only go down to 90-degree ambient, which they need to change someday. But
Well, here in Canada, for years, I was going around and helping contractors drop it to 70 or 60. All these a lot of units, right? Just 90, low condensing. You want to get some energy, you drop the condensing.
I think like Toronto, for example, the 0.04 ambient is more like 88 or 89 degrees anyway.
Yeah.
And obviously you can find nice tables that you can pick the unit cooler. And as I noted before, you'll see most of them will provide you the 10-degree TD automatically. If you want to size at a 15-degree TD, you'll have to bump it by a factor of 1.5. So those are kind of the slides that I wanted to show initially.
Yeah, because most of the people see this is what they see. If they go to a wholesaler, they'll see it doesn't matter if it's Heatcraft or if it's Keep Right or whoever it is. They're going to have some sort of chart. Emerson, that they have charts just exactly like this. When I was
Mhm.
training on Emerson, it's exactly like this. And then a lot of manufacturers now they use software.
Well, yeah, and that was my next point, is that for teaching purposes, having um, a student go through these charts,
Yes,
one or two or three times is I think a very good thing.
100 times maybe, two or three
But
times.
and that's exactly what we did at the Tecumseh University. It says, hey, here are the charts here. I want you to do, you know, size the equipment using these charts. Now, uh, the math is obviously not difficult, and but using the charts is cumbersome. And this is what a computer program is supposed to do for you.
Yeah,
Yeah. As long as you understand the procedure, there is no reason to use these charts. You use software.
yeah,
And having written this type of software, right now, I think I'm on my third version of it. Uh, I have something that I consider as good as anything that's out there. Um, and part of the reason is that, back in the day when I wrote my very first version at Tecumseh, guess what? The Tecumseh version only selects Tecumseh equipment. And if you go to the Heatcraft actually makes some very nice software, but they only select Heatcraft equipment. Russell only selects Russell equipment.
yeah,
Keep Right selects Keep Right equipment. Wouldn't it be nice if there was some software that, oh, you know, I've got this Tecumseh condensing unit and I've got this Russell unit cooler. I want to match these up.
yeah,
And you
exactly.
can do that with my program.
That's awesome. Just before we
Yeah.
get to that program, there's a question. What do you think about the difference in capacity for 404A and 448A?
Um, the On the unit cooler side, the unit cooler folks uh, have 448A as a higher capacity. Now, that's not completely, I don't completely understand how they came up with that,
Yeah.
but
Because when you look at the
but
compressor software, it says something different.
yeah, that's part of the one of the things that I had elected to do, at least with my software, is that I am using the manufacturer's published performance data the way they've got it published. I said, all right, you guys are supposed to know as much as anybody about what this unit cooler and condensing unit have as far as capacity. I'm going to use it. So, but to your point, um, I personally, I would expect in most operating envelopes for a condensing unit to have slightly more capacity on 448A than 404A. The drawback there is that 448A will run hotter. You'll run higher discharge temperatures.
Right.
So if you're employing some kind of a desuperheating valve to keep that in check, that's going to detract obviously from your capacity.
Exactly. And I've seen a ton of that, like in supermarkets, we're doing retrofits from 404 to 448, and it's like, why is all these compressors tripping off? Well, you need some demand cooling now, or liquid injection, or refrigerant injection. So,
Yeah, but
okay, excellent. So this is everyone. This is Andy Software. It's HVACR Advisors, ADVISORS.com. For those who are listening, head to that website and check it out.
Yep. If you see my smiling face there, you know that's you've been to the right site. Yeah, I had a graphic artist complain to me, said, Andy, you got to find another promo pic than this, but all right,
That's
it works.
perfect. Yeah.
But anyway, this is the main page under the, by the way, I did talk a little bit about the cold topics. This is where I've got a bunch of articles here. And if you're interested further reading about the AWEF standard, it's here. But any of these can be freely distributed for educational purposes. And under the apps section, I've got a number of apps here. The walk-in cooler freezer equipment selection is is the topic today. One thing to keep in mind is that these apps are mobile kind of friendly. I've got them. I wrote them myself, and I describe them as kind of mobile, somewhat friendly. So if you got your iPhone or Android, you should be able to have no trouble running these selections on your phone. So I just bring this thing up here. As I pointed out, I've got all the manufacturers, all the main manufacturers here. You know, got to keep and Ref Plus. Ref Plus actually does a very nice job publishing data.
Yeah.
And what I'll do is just stick with Heatcraft here for a moment. And I got a choice of indoor or outdoor and the different voltages. And I'll leave them alone for the moment. And here are the refrigerants that are available. AWEF compliant, it's by default checked because most of your applications will require it. But if you're interested in not having AWEF compliant equipment, you can uncheck it. It also gives you the option of if you want to include units that are no longer manufactured, you can click that if you want. But I'll just get this back up. Now, it has geolocation capability here. What I'm going to do is when I click that, since we're, that's kind of funny.
Since you're in Argentina right now?
Yeah, well, it's because because of our connection here.
Yeah.
If you were, you know, with a regular connection, the heck with that.
VPN. Oh, you're just,
What I'm going to do is I'm actually, since I am going to, I got all these. This is data from ASHRAE, so I'm going to go to. Let's see. Since I am going to be presenting at the HVAC Excellence Conference, I decided that's being held in Las Vegas next week. I picked out Las Vegas and it filled in the design ambient. It's the 0.4% temperature. So it looked it up automatically so you don't have to bother with it. And let's say we're interested in a cooler, and I'll just use 35. And let's say 7,000 BTUs, just to pick a number here. What you see here is the program nicely displays a chart, which I thought to myself, you know, nobody wants to look at numbers on a table. Take a look at a nice chart here. And what it's doing is retrieving the performance data from the heatcraft climate control literature and displaying it in a nice graph. All right. Well, one of the things that you notice here is that the lowest ambient that they have is 90, which is kind of unfortunate. But in the case of Las Vegas, who cares? You know, you're not, and 95, 100. And it went ahead and it selected the half horse compressor, and it's showing a 67,000 BTU, the closest it found to 7,000. Now I can click on that, on the next one larger. So here's 79,000. So if I were interested in a little bit larger condensing unit, I can do that.
7,900.
7,900, so yeah, 79.
Going from 6,300 to 79,000.
Yeah,
That's a big jump.
yeah. And it automatically figures, I put 35 as the box temperature. It's going to use a 10-degree TD.
Yeah.
If I want, I can change this if I want. Change it to 15 or whatever, or drop this to 20 if I wanted a 15-degree TD. But I'm just going to leave it at 10. And if I click next, it's going to assume that I want a climate control unit cooler. But if I really wanted to, I could pick any from this list. And let's just stick with that. I don't know, let's maybe go with the 115 volt. Stick with the low profile. We've got various models here. And a lot of people like buying unit coolers with mounted components, so I can specify that. We'll leave AWEF on there. And if I wanted, to put 2 or more unit coolers in there for this small one, obviously the one's going to be fine. So what you see here is some options. With the air-cooled models, you only get one rating, so that's why you get this flat line. All right. And the calculated TD is 9.9, which, looks pretty good. And I could change that to the next smaller one, which gives me a 12.2. And just for argument's sake, I'm going to pick this one. Let's say this is kind of a beer cooler type of thing. And I click next, and what you have is a system balance chart. It will actually go ahead and figure out exactly where the unit cooler and the condensing unit balance. And as you can see right here, it balances right at 11.8 at this capacity. So
So it took the condensing, which was 7,900. The one you picked was 7,950. Then you picked the evaporator, which was, I believe, 6,500.
Yeah, I can
just
go
double
back.
check that.
Yeah, go
Sorry,
back.
8,000.
Yep.
It was 8,000, and then when you put them, match them together, it brings it to a 7,600.
Yes.
Okay.
Yeah, and it happens to be an iterative calculation. One of the interesting comments I got from a person here, a wholesaler in Texas who sells Russell equipment, and says, Andy, I use your software, and you're always about 1/10 of a degree TD different than the Russell equipment. And I told them that the reason for that is that Russell software isn't doing the final iteration. It isn't putting everything together. What happens is when you change the TD, you change the condensing unit capacity. So it becomes an iterative calculation. And it's not a big deal for a computer to do it, but you may end up having the computer do this several hundred times before it finds the exact solution. So that's the reason I
So now,
that
okay, so now you size you're looking for a 7,000 BTU box, walk-in
Mhm.
box. This example, you had the option of going with a 6,500 or 6,700 BTU condenser, or a
Yep.
7,900 BTU, which is over 10% larger.
Hmm.
Is there any way you could size it using the smaller condensing unit or not?
Well, yeah, you can always go back. There's
And there is a
you,
question too when you get that. Does it give
yeah,
you runtime? That's another question in the chat.
the runtime is the runtime actually happens to be a load calculation
Mm,
problem. I have a separate program for that.
okay.
When you when we start here and required capacity, you're building in the runtime.
Okay. So the
So
runtime's
let's
built into that. Okay,
yeah,
perfect. Yeah,
absolutely.
that should answer
So
that. Yep.
so I in fact, one thing I'll do real quick, just show you,
Yeah, do that.
and I won't do that. Here's a load calculator. This is where one would do a load calculation, and this would be a separate discussion all into itself.
Yeah.
All right, and let me just show you the front part of this. Let's just leave it in Auburn
Yeah.
for a moment. But you've got the transmission, infiltration, product, and internal loads. You can step through it all. And then you've got the summary. Here in the summary is where you adjust your runtime, your safety factor, and there's something called a diversity factor, um, which you can adjust to calculate the load.
Mm.
That
What does that mean, the diversity factor? I know the safety factor. What does the diversity factor mean?
um, basically what the diversity factor, and as ASHRAE defines it, is that when you do a transmission load, infiltration load, product load, and internal load, not all of those loads peak at the same time.
Mm. Okay, that makes
So
sense.
yeah, and what ASHRAE recommends is you use a diversity factor of 0.85. Basically, it reduces your total loads by, it uses only 85% of it because it's recognition that you're not getting all the peak loads at the same time.
Yeah, totally makes sense. So this, you would use this first. You do your load calculation first before you go and start selecting your equipment. So, and it looks pretty
Yep.
straightforward. I think I went through this already once before and just fill the box in to see what
Yep.
populates. So we did this. Now we got that 7,000 BTUs. We're in there
Yep.
sizing it, and
Yes. And one of the things it will remember,
that's perfect.
within the session. So, but yeah, that's where you come up. Now, it's been my experience, and it's kind of unfortunate in a way, that most equipment is sized with quick load charts. So most people use a heat craft chart. Actually, I have one for Tecumseh, gives the dimensions of the box.
Yeah, I was
Is
8 by 8 by 8,
yeah,
4-inch insulation. So
yeah, but it's and it dismayed me, but it's okay. I said, all right, you want to use your quick load chart. Most of the time, you're oversizing equipment anyway with the quick load chart.
Yeah.
But
But that's
I
where you're
would,
running into problems now, and a lot of people are, especially when you go to do an energy update or upgrade on a system, and all
yep,
of a sudden it's grossly oversized.
yes, yes.
I've seen a lot of that.
But one of the things that I wanted to just to show here to kind of end things here a little bit is that when you size, excuse me, the unit cooler at the 109 condition here, the thing to keep in mind is that you need to ask yourself, at what ambient is your equipment operating most of the time? All right. And I go through some numbers in my main presentation, but interestingly enough, you're going to find out that if you use 90 degrees to size the unit cooler, that's a better number to use. All right. So, not to confuse things here, we first started out, using the 109. All right. And we ended up with a half horse uh, unit. Um, it would be better to use 90 degrees because and you're going to use the same condensing unit. Okay, it's already selected the half unit anyway, even at the 90. But this is a better. You're going to get more capacity out of the unit at a 90. And if one were to just go through this real quick, you may remember, as it turns out, it's selecting the same one. So maybe not a perfect example. It's still selecting the 095 unit cooler in this particular example. But you should do it twice. In other words,
Yeah.
start with the design ambient and then look at that same condensing unit at a 90-degree ambient temperature and see how your unit cooler matches up to that. So,
And I recommend doing that all the time when you're sizing any type of equipment. You want to understand where your max is going to be, where your minimum is going to be, and just see what range it's going to be in.
yeah, that's exactly right. And that's really the point I was going to make in Las Vegas is it's fine to use the point 0.4 ambient temperature for sizing the condensing unit. You want to make sure you're getting the capacity you want. But when it comes to sizing the unit cooler, use 90 degrees or less. Now, the problem with using less than 90 degrees is that, like Heatcraft doesn't publish anything lower than 90 degrees. So if 90 degrees is the lowest they've got, you can put that in the program here, and it gives you the 90-degree capacity. Just for example, you only have about 6,800 at the 109, but at 90, you've got 8,000. All right. You really should be sizing your unit cooler at that capacity.
Makes sense. So if they
So,
do size it, what's some of the issues they'd run into if they went with the 70? What was it, 6,800, the one that was
yeah.
the smaller unit? What could they see?
Well,
Um,
it's more of an efficiency thing. Yeah, getting back to my slide, let's say you've got a mix unit cooler. Let's say you've got a freezer and you want to size the unit cooler at a 10-degree TD. Um, if at a 90-degree ambient, let's say it's running at 13-degree TD, that's not so good. You know, you should have a larger unit cooler. And maybe at 109, it's running right at 11. You think, oh, 11, that's great. I just selected at 109 ambient, and everything looks great. No, you should take a look at it at the 90-degree capacity also, and that way you get a better matchup.
Yeah, it totally makes sense. Awesome. Yeah, no, it definitely makes sense to me because I definitely did quite a few sizing and selections on condensing units and evaporators before, and it's definitely an art. It's you want to make sure you select the right ones, and I'm seeing it in different different ways engineers are doing now is like dynamic selection, some people call it, where you got that 1% of the year where it's really hot. And I see this in larger applications, but that 1-2% of the year where it's really hot, coming out with a different solution for that 1 to 2% of the year instead of grossly oversizing systems.
Okay, well, I'm continually working on the system. I
It's
am
really
starting
great
to
that you
add.
have, sorry, but it's really great that
Yeah,
you have all the manufacturers in here. That's the game changer here, right? That,
I yeah, you you want to put a keep rate on there,
yeah,
and you want to put a say like a Russell. Hmm,
yeah,
there you go, and you just do a system balance. You got keep right, and by the way, I do like the fact that keep right they do provide an 85-degree ambient, but they're used to the colder weather, right?
yeah. Well, it's spring now. Spring's here. Might be snowing outside right now, but it's gonna. It was nice today. It was nice today. We do have a question. I think it
Okay,
was to the load calculations when you had the diversity factor up there.
yeah,
They
we'll
said they
get
asked,
back to it.
so you don't use a 10% safety factor. I think it
I
was.
yes,
Yeah, I think it was there.
yeah, the at issue there. Let me just we'll hold on here. Get a get a location. This thing stops until it knows where you're at. Um, the summary,
Yeah, there's 10%.
there's three. Now, the safety factor and the diversity factor work against each other.
Okay.
Now, if you're adding 10%, actually, one of my wholesaler friends in Texas says, in Texas, we don't have a diversity factor. It's 100%. All loads hit maximum at the same time in Texas. So you can actually put 100%, which
Okay.
eliminates the diversity factor part of it. You can have the 10% and your runtime, 18 hours per day is pretty typical. But if you want to use a little bit smaller unit, you can go to 20. So any of these can be changed, and these are just factors that are applied to the total of your 4 different loads.
Yeah. Awesome. So you need to get to this website and check it out. What is one of your favorite? Is this one of your favorite things about your website, or what is because you got a lot of cool things on here. I've been promoting and sharing this with a lot of people over the last year. What's your favorite thing on this website that you've done? Because you created a lot of this.
Yep.
You did, yeah, ice
Did it all.
meters is is great for great resource for lots of different manuals in there. I
Yeah,
do have to
the
talk to you
Ice
about
Meister back, Charlie, this one might be worth,
definitely. I show this to so
Charlie,
many
yeah,
people.
Bartlett is, he's been in the industry. Actually, he passed away a couple of years ago. Um, but he had a website that he collected all sorts of manuals, old manuals, whatever. And I recent I even have a Google search of this section of my site, and this is just a collection of everything that he did. And I had two or three folks go through his site before, you know, they were concerned that it would go down because, you know, his wife still lives, but at the moment she still leaves that server on. But I just kind of gathered everything off of his site and put it on my site here.
And there's
And
hundreds of
oh
documents
yeah,
like and countless manuals that I've searched and I found there. And the one of them's the piping guide by Garth Dennison. That one's on there.
yeah,
That's
yeah,
where I actually
yeah,
found
refrigerator.
this website because of that, right? So because I
Yeah,
always recommend for anybody in refrigeration to understand the piping of the engineering of a system. That's how you get better as a technician out there, is understanding the engineering of it. And I always promote
exactly.
lots of stuff like that.
But yeah, and anybody who wants to, I do have a um, anyone who has really old manuals, they can actually uh, upload those or send them to me. I'll just stick them out there.
Awesome. I know a few people that collect manuals for like the last 10 or 15 years, and you know what I mean? It's because sometimes even on Google it's hard to find them, you know. And then manufacturers, what they do is they delete them. They'll pull them
Yeah,
off websites and then they're gone. But
absolutely.
you need
And they're
this,
gone.
yeah, and you need this one manual. I couldn't believe it when some of the manuals I seen just go away just like that. I'm like, they were all here. Now they're all gone. It's like, where do I find this information now? So Andy, I want to
Uh,
thank you so much for taking the time to show us a little bit about what you're offering, what you can, what your website does, all the different apps. You guys got to get into this and check it out because there's a lot of different things in there that can help you. You know, from engineering stuff to technical stuff, lots of cool things. Any final words, Andy, that you would like to leave everybody with?
no, I appreciate the opportunity to show this, and you know, I still keep reasonably busy in the industry. So
That's awesome.
my and this is something I enjoy doing.
Awesome.
So send me an email sometime if you have an idea for an app or an article or whatever.
Awesome. So that's perfect. So head to Andy's website. It's HVACR Advisors, ADVISORS.com. And then you can email Andy at HVACradvisors.com. Just like he said, I want to thank you, Andy, for taking the time to do this. It's very nice to meet you. I want to thank everyone for taking the time tonight to learn a little bit about equipment size and this cool software. Have a great time at the event in Las Vegas. That is the HVAC Excellence Conference. I've been there many, many times. And I'll see you all at the next Refrigeration Mentor podcast. Thank you so much, Andy. Thanks,
All right,
everyone.
and bye.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.